Alright, trying to use a little bit of prior knowledge here to start off this one. Okay, this one is about rationalizing the denominator, which means, again, like I said in a previous video, we can't have a square root in the bottom. But what we know is that when we times these together, that also means that we can put them together like that, if they're both under the same sign, which would be the square root of 25, which is 5. And really that makes sense because there's 2 of these, so that would be 5 squared. And the square and square root cancel each other out because I go 2 divided by 2 like we said before. So from there, that kind of brings us to some more. Remember how the square root of something divided by the square root of itself would just give me 1, right? So the square root of 2 over 2 equals the square root of 1. Again, that's how they got back to 1. Now when you're multiplying fractions, this is kind of important here. When you multiply fractions, you multiply across. So like 1 times 2 equals 2, 2 times 2 equals 4, and you reduce that to 1/2 because I could divide each of them by 2. But you multiply across, okay? Alright, all of that is stuff that we do know already. Maybe we've forgotten, but you should know that, okay? Now again, what's the big deal here with rationalizing the denominator? Can't have a square root in your denominator, or bottom if you want to write that, okay? Can't have a square root in the denominator. It's like math rule 101. Can't have it, okay? So what do we do to get rid of it? We multiply. Maybe we should put a star on this one because this is the big deal. Multiply the top and bottom by bottom. So if you want, multiply the top and bottom by the denominator, okay? And then remember that only multiply in square root with in square root, or out square root with out square root. That'll probably make more sense as we go here, okay? So what's on the bottom? Square root of 7. Can't have it. So that's what we got to do to the top and bottom of both sides. So square root of 7, square root of 7. Because again, the square root of 7 divided by the square root of 7 is 1. We're timesing this by 1 even though we're changing it. Okay? So on top, I can't multiply what's out with what's in. That's what I was trying to say here. We can only multiply something that's under a square root with something that's under a square root. So that just becomes 5 times the square root of 7. Can't combine them. But these are both under the square root sign, so I can't combine those. That's square root of 49, which we know as 7. And so I just reduce it. And now my square root has gone away because I have 2 of those to make that. Done. That's how we do it. Okay? Let's look at another one. Okay? So this one, square root of 2 and square root of 2. I get 2 square roots of 2 over the square root of 4. Can't do the top. I can do the bottom. They're both under square root, which is what I want. 2 square roots of 2 over 2, which, because the square root of 4 is 2, and then 2 divided by 2 just cancel. I get square root of 2. So simplify them when we can, right? This next one, square root of 16 over square root of 17, is really 4 over the square root of 17, right? But I can't add that in the bottom. So square root of 17 here, square root of 17 here. I get 4 square roots of 17 over. Now here's the thing. The square root of 17, I'm not sure anybody knows that. Okay? Well, actually, 17 times 17. 17 times 17, I think it's 389, but I should probably look that up. Just a second here. 17 times 17 is 289. I was wrong. Okay, so square root of 289. But something tells me you're not going to know what that is. But remember what we're doing here, right? 2 of these gave me 1. Square root of 2, square root of 2 gave me 2. Square root of 17, square root of 17 is going to give me 17. That's how it works, because when I times these, I get there, and the square root of 289 is that. But stop thinking like that. Square root of 2, square root of 2 means 2's got to be on the bottom. Square root of 7 means 7, right? Square root of 17 means 17, and so on. And so when I do this one, like so, I get 4 square roots of 3x there. Can't combine them. On bottom, this is the square root of 3 times 3, which is 9, and x times x, which is x squared, and the square root of 9 is 3, and the square root of x squared is x. But I don't need that because I know that whatever this is always what's going to be under there. Okay? And that's it for that. Okay? Pause the video. Maybe try the 2 problems at the bottom here. Okay? Come back, check your answers. Pause it. Okay, so for this one, whatever the denominator is, times it to the top and bottom. On bottom I get square root of 9. On top I get square root of 30 because they're both inside, so I can multiply them both inside. 4 doesn't go into it, 9 doesn't go into it. There's nothing I can do to simplify that, but the bottom I can. That's 3. And the top just stays square root of 30. Simple as that. On this one I get 1 times the square root of 5x, which is just square root of 5x. On bottom, again, I get 25x squared. But look, the bottom is 5x, then the bottom is 5x. And that makes sense because the square root of this gives me 5. And the square root of this, I go 2 divided by 2 to get 1. Some of you are going to want to cancel this. Cancel those 5x's out. Don't do it! Because that's under a square root and that's not. They don't cancel each other out. It'd be like saying the square root of 4 over 4 would cancel. But the square root of 4 is 2, and 2/4 does not cancel each other out to give you 1. Okay, so don't do it. Okay, that's it. That's all you do for that. Okay, this is under the rationalizing the denominator section of the assignment here. As you can see here, there are 4 problems right there to work through. Do those on a separate sheet. Okay, and check out the next video for the last part.